Good afternoon, colleagues from around the world, and welcome to this, the third of the series of webinars being conducted by our global partners. And I can tell you that we've got something exciting in store for you today, because we have colleagues from the GF Group presenting on the subject of plastic injection molding, emerging industry trends and innovative machining solutions. But before we start the presentation, let me just comment that over the weekend, I shall be traveling to Germany to join to host conduct the General Assembly, the ISMA World General Assembly, which is being hosted by our German associations, VDMA and VDWF, in conjunction with Messe Stuttgart. For those of you who have registered for the General Assembly, I look forward to seeing you again. For those that haven't, it's not too late. It may put our hardworking secretariat under pressure, but you can always fill in the registration forms and join us there. Today, we have 91 registered attendees coming from the following countries: Algeria, Brazil, Canada, China, Croatia, the Czech Republic, Estonia, France, Germany, India, Israel, Italy, Japan, Mexico, Portugal, Singapore, South Africa, Spain, Switzerland, Turkey, the UK, and lastly, but not least, the USA. I think it goes without saying, we are truly fully represented globally today. But you don't want to hear from me, you want to hear from the GF Group. Now, I'm going to pass you over to the colleagues who can introduce themselves. You'll know why when he does the introduction. So I apologize for not doing it personally, but I can say, having had some insight into what's going to be presented today, it's worth listening to. Over to you, colleagues from GF Group.
Thank you, Bob, and thank you, Manuel, for inviting us. Today, we are going to briefly discuss what are the ongoing consumer trends from the application point of view, what the OEMs are doing, and how we can support as a machine tool builders to mold makers who have to, in the end, implement these trends. We will finish by sharing a small success story or a small story from a customer in Austria about automation and what he gained. Before we begin, a small introduction on GF Group. So GF Machining is part of Georg Fischer Group. Georg Fischer has a long history of 200 years. Started in Schaffhausen, so north of Switzerland, bordering Germany. We started with foundry business and some industrial manufacturing in the old days, how it used to be. Since last 110 years, we are listed on Swiss Stock Exchange. We in the Georg Fischer or GF Group, we are three companies: GF Piping System, which is the oldest one in the group, GF Machining Solutions, and GF Casting Solutions. Together, the annual revenue is close to 3.7 billion US dollars, Swiss francs. More about GF Machining Solutions. So currently we are headquartered in Switzerland, in Biel, employ around 3,000 employees all around the world. Production facilities range from in Europe, China, and we have 33 sales companies who are catering to the needs of individual regions and countries around the world. If we briefly look at, these are the competence centers, headquarters, and production areas available all around the world. So we care about everyone around the world, mold makers, part manufacturers in many segments, supporting the manufacturing industry. We also have a long list or with research organizations to help us develop new solutions, innovations, continuously making progress in the machining or the machine technology side. Today, we have a portfolio of around 8 different technologies. So obviously the milling solutions, which includes high speed, high performance machines, and also for aerospace, engine, plus specialized dedicated machine. Then we have EDM machines where we have the die sinking, erosion, then wire EDM, and also drill EDM. Laser, which is fairly new, is laser ablation, includes texturing, structuring, different range of laser sources. Additive manufacturing, we have a partnership with 3D System to provide metal additive manufacturing solutions to industries at the moment. In micro machining, we have a small unique technology with Microlution. It's based in Chicago, which is used to create fine holes and small metal machining in various aerospace or electronic industries. Then we have our own spindle technology, which is a StepTech high-speed spindle. The tooling and automation through System 3R based in Switzerland, and we are continuously working to improve our digital transformation portfolio and solutions, which is important now for manufacturing in the mold making, but also manufacturing in outside of mold making in production, where you need to keep track of many things. You need to improve your quality and cost. So now we come down to or start discussing what is the topic of today. So how we can support this using our technology. First, a brief. The unique portfolio of our technology in a combination with milling and die sinking, laser, EDM. This is mainly to has increase our expertise in offering solutions for mold and die. Today, our focus mainly is in 5 segments, which are for automotive, ICT, electronics, packaging, and medical mold and die industry. To create the parts, to create plastic components, and to create efficiency in with the die tool in electronics or automotive for EV. So we have a large customer base who use our technologies in mold and die industry. So coming to the innovation and trends, we started to see how we can explain the impact of mold and die industry. Today, mainly what we see in the end is OEM consumer products. So we started from there. We have some products which we are offering or which we are working with mold makers and OEM, and what we see in the market. So a selection of these products we will briefly go through and try to understand how they are impacting and what are the changes in OEM and consumer applications which are important for us as partners in mold and die industry to understand. First, this is just a small bottle of plastic. Now, usually in a plastic bottle, you have certain element or an amount of plastic to be used, even in the ones which are non-reusable. So you drink the water and you throw the bottle. It involves PET. This is a new product created by Nestle, which has aluminum casing, and the internal part, which is made with the PET mold, is produced by using 40% less plastic. So now you have, if by using this product, you already add to the value chain by reducing the amount of plastic you use and you recycle. This kind of innovations we are industry is witnessing, where you reduce the amount of plastic you need to produce the part in functional. The good thing about this is you, for the mold makers, you have a value, because then you have to create a special mold with a high surface finish, and also with good surface integrity, because now the wall is thickened by 60%. This reduces the plastic, which is mainly driven by the uh, trend the industry is seeing, or the requirement from the industry to reduce the plastic, but still create the value, because you create a value here. Second one is an example from Aptar. So this is a complex design of anti-spillage caps and closure. It involves two materials. One is the plastic and one is a kind of a thermoplastic, rubber. So the complexity here is the how you create the cavity using a complex 3D shape, so that it adds a functionality and you will not spill it. This could be used for water bottles, but for also for oil. And this anti-spillage also increases the time or the long-term usability of this product. This is a functionality which has added by increasing the complexity on the shape of the product, then obviously in on the shape of your cavity itself. Then we see another example from automotive. So from packaging, and let's see from automotive. This is radar housing or the sensor housing for Volvo XC60. This housing has a specific function, that it has control over gloss. You have no gloss. What it does is, by controlling the gloss, you improve the function of the radar, which is housed inside this uh, plastic body. By controlling the gloss, we have improved the production, or we have improved the functionality of the sensors which are embedded inside. This way, the autonomous vehicle, or what the trend in the automotives, are being tackled through plastic injection molding. By controlling the gloss, you improve the functions of the sensors which are embedded. Fourth example, it's a audio system, usually for high-end car. To improve the functionality here is more about aesthetic and how you reduce the post-processing and also environmentally harsh processes from your production chain. So for this example, Harman Kardon, they created using a laser etching process audio system for Renault cars. This is mainly for aesthetic, but also it impacts or it improves the sustainability of your whole production process by using laser manufacturing or other technology instead of normal etching. Then we go to a small consumer example. This is a new product designed by Dove Group. This is mainly for long-term usability. Now, when we talk about long-term usability, there are two impacts. First, the product you design in your plastic needs to hold the shape and needs to hold the value for a longer time. That means you have to use a harder plastic.
We seem to have a frozen screen.
Is it okay?
I think so. You can move on.
Yeah. So By using the particular plastic which can last for a long term, you improve the product, can be used in a reusable way for a longer lifetime. This automatically reduces the plastic also, the consumption, because now you don't have to buy one after another uh, plastic, but you can reuse harder plastic for one time shot, which lasts longer time, and you can use it in a reusable way. Then this is another example where we collaborated with company DuPont. They were testing or usually for chemical packaging and storage. A glass is a good material because it is chemically inert. Now, with DuPont, they developed a particular plastic which has the same likeness in terms of texture and feel to glass, but it is not glass, it is a plastic. This was mainly developed to store chemicals and in the perfume industry. We developed this mainly, the goal behind was sustainability. Sustainability in the sense the processing chain of glass is not as sustainable. Glass is sustainable, but the processing chain is not. So to remove that part from the your value cycle of product, they developed a special plastic which can be reused to replicate the glass-like effect and also hold all the chemicals, which has a potential in wine industry and pharma industry along with perfume industry. Another example, which is a very good example, is EV products. So basically the charging points, which we see that there will be a big market, it's already ongoing. The molds are very complex because you need to have multiple channel inside the mold itself. You have the sealing rings. You have a use of multiple materials inside the same mold. This improves the functionality of your charging station, but adds a complexity in terms of what we can do with the mold. So the molds are very high value because of all the reasons I listed just now. But in the end, it provides a functionality, and this is what the industry is going to. No more simple molds. If you need a mold, it has to add a real value in the process. The final example for this small slide is from Volkswagen Group. This is a dashboard picture. This is a picture where we are working on with our customer. The main goal here in this dashboard is the dashboard is quite long. When you would like to do some kind of surface preparation on this dashboard mold, you have to use a segmented mold kind of in the cavity. The problem is you cannot have a smooth and linear surface because you need different textures at different points. So you will see the lines and everything. The stitching lines, the movement of from one texture to another texture. To reduce this complexity, the company asked, okay, create the same texture on the complete mold because we would not like to do it. Or it's impossible to get the part right if you do in a different cavities. Using in a single cavity, you have to use a process which you can control the quality with sharp features. By using this integration of multiple features on single mold cavity, the brand was able to achieve a sequential quality on the whole dashboard. This also has one factor that when you need integration, it is important to have the value defined before the integration. Then just doing an integration for the sake of it. Once we have defined these consumer trends, which are driven by plastic injection, OEM, consumer demands, policies, and regulations. What it comes down to is all the applications, all the requirements could be subjected into three categories from mold making, mold manufacturing point of view. First is the design. The design part will add either a functionality to your product through the mold or an aesthetic which you need on your product because you are targeting a specific market. Then obviously the next part is machining of the mold using the right machine tools, creating the cavity, using the right strategy so that you have the material removal rate, the surface finish and homogeneity you need to produce any of the parts which we discussed or any of the part which you might be making. Contour accuracy and other quality factors. Third, which is more important and beginning to get even better or more important now is from the cost point of view. Producing a mold is important, but how you produce is very is being looked after in great detail now. You produce a mold, before you produce, you have to really evaluate the value you can get from the part which you would like to make using this mold. Additionally, the maintenance of the mold. This is another important point which is ongoing. You make a mold in a way so that you can have you can optimize your productivity, you can maintain the mold, you can maximize the reusability of your mold elements. The third part or the point is post processing of injected plastic part. So this is another which we are seeing now. When you have a part like maybe this, when you would like to have a very high gloss, usually you do some post processing on the injected parts to remove certain lines, to remove certain partition lines, to increase or to use a painting or the stickers. But all of these are manual processes and all of these add value in terms of add cost when you would like to do that. So the trend is once you inject the mold, the plastic part should be close to what you expect to be integrated directly into your component or assembly. This is very important because it also has an impact on the cost, but also because now you remove all the harsh or environmentally harsh processes from your chain and you improve the productivity and the quality you need to produce parts at a faster rate. More on this topic we will see in the next slides. So next we will see a pre-recording session with me and John Paul Nicole, who is part of our laser business support and product management. And we will discuss more on these and some two application examples using a solution of milling and laser combination. So please enjoy.
Hello, good morning, good afternoon, everyone.
Hello, good afternoon again. So I'm here joined by John Paul Nicole. He is our head of laser technical TSE support and for new business development regarding laser technology.
Yeah.
So welcome, John Paul.
Thank you for this invitation.
Yes, sure. So as I explained before, we discussed few examples of what is the market trend ongoing. And with Jean Paul, we will try to explain from the mold machining point of view how with our 5-axis milling and laser solution we can achieve certain process manufacturing process expertise or simplify the process for the
Yeah.
advantages which our customers in mold making can give.
And the combination we can do with
Yes.
these two technologies.
So
Yeah.
yeah.
For sure, we're in laser texturing. We're either addressing aesthetics, but also some functional surfaces, whether in the mold, and this comes from the design itself. As you can see on that picture, is not only flat. This is a 3D complex shape, as a mold is usually. For sure, we are talking always about material removal, surface roughness, homogeneity, contour accuracy. This is mainly on the preparation side, and here it will be 5-axis milling. And we will have a look on the cost behind for the mold tool, to maintain the tool, but also to take part of the post-processing in the plastic injection.
So as we discussed in the morning that there are sustainability aspects, there are new plastics to be injected, there are new values to be created using your own product through mold and then injecting it in the plastic.
Mhm.
All these trends could be summarized from the mold manufacturing point of view in these three pillars, and where we are trying to address through our solutions. So today our discussion is going to be focused on 5-axis milling and laser technology, both 5-axis. So
Which is
before-
5-axis too.
yeah. Before we move forward, a small video of our product introduction, a 5-axis high-speed milling machine. This was basically a simple introduction for you guys on the machine. When we go next to the laser section, I will let you know some comments.
Every step, breath, every moment matters. Every second counts in the search for inspiration to capture the perfect form. We're with you, embarking on a new era in manufacturing. With our Laser S manufacturing solution, the versatile machining system enables new ways of working to answer the toughest texturing challenges. With a high-speed 3D scanning system and wider marking field, you can create even more. SmartPatch technology optimizes your work for maximum performance. The soul of the machine, a unique laser head to achieve immense complexity. Moving fast to a simplified manufacturing process. You're always connected. And with expertise available from our academy, you'll accomplish even the most challenging projects, enabling the execution of the most complex parts while the finest grains are achieved, giving you the power to turn inspiration into perfectly designed, flawlessly produced reality. Laser S. Innovative texturing. Accelerated productivity.
Okay, so great introduction to Laser S series. How a 5-axis laser technology machine could be used in, let's say, to address some of the challenges which the mold makers are facing today?
Yeah, basically every part able to be milled in 5-axis, where we can access with the laser beam, but laser beam is smaller in terms of size and longer in terms of length compared to a tool in milling. Usually every kind of part you are able to be milled, we can engrave, okay, or texture. Means we are addressing complex 3D cavities, for sure. Also the design, if we are talking about design itself, means the scheme of the part could be whatever you want. It's coming from the design studio, the designers, product designers with ideas, and then we try to apply on the mold in negative, for sure, to get the one thing. The very important point in mold requirement is especially repeatability, and for different mold made in different parts of the world, or several cavities made into a multi-cavity mold, for sure.
Okay.
And then process simplification. This is every time, every visit we have with customers. It's really a request, a deep request to cut down the cost, especially, and to simplify the process. How we can address that? This is very simple, I would say, having accurate and stiff machines, having a set of laser sources to be able to address different purpose. We have developed a full digital process flow. This is our proprietary development. For sure, as said before, we're using 5-axis mechanical machine, but also 3-axis scanners to move the beam over the surface. And we are delivering not only a machine, but we are developing a full solution with the software, which is very important to know. And on top of that, we're mastering the process from laser down to the part.
Okay. And this software includes the CAD CAM, the designing, and how machine can be.
Yeah, it's very simple. The native format, you are designing the mold, whatever it's CATIA, NX, and so on, Creo. We will use the native format, and then we will use our CAD system inside the suite we're having, the software suite we're having, and we are using Rhino 3D
Okay.
to import the CAD model, and then we work on that model.
Okay. Okay. Great. So using this, as you said before, we saw an example in the video. This kind of bird, what we say in-house.
Yeah, in-house, it's a complex shape. Even by milling, this is quite tough to get a very nice and very accurate part with a very nice homogeneity of the surface coming from the milling, which will be then textured with the machine, the laser machine. On that part, we applied 4 different type of texture. The honeycomb you have seen before. We have also developed a specific strategy of laser blasting to do a kind of sandblasting, to replace sandblasting, but also to do some EDM VDI replication. Okay. Engraving, for sure, on the border of this shape, there is a sentence written. And for sure, on the bottom of this texture, there is 2 materials. The wings are made of aluminum, and the pedestal is made of steel. And we applied also some very fine texture. This is brush pattern texture.
Okay. So as I understand, we are able to do all this in a single setup on the same machine.
Absolutely, absolutely. And also moving from one machine to another through automation or not, through the System 3 tooling.
Okay. So if I have one machine, I am able to do a lot of things, lot of textures, and address most of my mold making, surface preparation requirements through this technology.
Absolutely. Yeah. Most of the requests from the mold making is not only texturing the surface, there is also some grooves time to time to make, or some logos for the, say, the brand, or to engrave the part number or the cavity number.
Yeah.
All these things could be done on the same machine with the same laser and with the same setup.
Okay. So this is good. Let's see what else our laser machine can do. It looks promising for now.
Yeah, but still, and we can see there the 3D cavities.
Yeah.
All of them has been done either by turning or by high-speed milling here, and we need the shape of the part done. The laser will not remove a very high volume of material. This is not the topic, and this is not the, I would say, the performance of the laser. We are talking about the skin of the surface.
So the good thing is you need to buy a milling also with the laser machine.
To a mold maker, for
Yes.
sure, without milling machine, it will be a bit tough.
Okay. So one more thing I have in mind is few of the customers, when they see this part, they ask about what about the stitching lines, because they address they have seen these kind of issues when they are doing texturing with either etching or some other technology.
First of all, we are developing this software for laser texturing 5-axis since 2000, 22 years ago. And with continuous improvement, we are releasing at least 1 to 2, I would say, improvements of the laser with new functionalities, new on the software, I would say. And then we are managing this, I would say, patch lines through the strategies, and especially the one you see on that screen with the honeycomb shape. We are using, I said before, this smart patch texture or texturing to avoid, to cut down the patch or the design when it's not necessary.
Okay.
And this is patent.
Okay. So it's our own patented
Yeah,
smart patch is the name.
yeah, this is right.
Okay. So we can do a lot of cavities. What about materials?
Material, it's very interesting. We are not having the same constraints compared to chemical etching. Whatever it's the steel kind, like stainless steel, hardened, not hardened, we are not dependent on that. Could be also aluminum, could be polished surface or non-polished surface. Here you can have tool steel or mold steel. The cavity on the right, this is Stalax, polished, optical polished, to be able to replicate some very nice details. And in the center, the PET blowing mold, this is aluminum, usually.
Okay. And so away from the mold, we are also able to do some kind of ceramics and a lot of materials.
For sure. Tungsten carbide, silicon carbide, silicon nitride, zircon is also depending on the laser sources. To certain kind of material, we need to use a specific laser source, like femto time to time to machine, for example, sapphire, glass, or zircon. This is required.
Just good to know away from the mold also.
It's quite wide. This includes molybdenum.
Okay.
Design-wise, it's, I would say, limitless possibility, because it's really everything we can design, we try, and we have developed the tool to be able to apply that on 3D model.
Okay.
Could be for aesthetical ones or for functional ones. Like we are really well introduced in the automotive lighting points, and this is not aesthetic. It could be aesthetic, but this is also functional for diffraction of the light,
Yes.
especially.
Okay. So, what about the features? We see a lot of things
Yeah.
that can be done.
Typically on the software we are delivering with the machine, we do laser texturing, means texture the surface as we have seen with the honeycomb. We can do also laser blasting, which is a specific texture. We can do laser engraving to do some grooves like you can see on the second bubble, but also doing some light engraving or marking, as said, and also fine texture. And everything is a combination of texture coming from a bitmap file from Photoshop, for example, combined with the surface of the mold or the part.
Okay. Before we move forward, just one more question. If I have a texture or whatever, I can do this with this laser machine, but I can also do it with other laser machine
Mhm.
from our like laser S to laser P to femto,
Yeah.
or I can do the same texture with the next generation machine down the line after 5 years.
We are developing for sure the strategies for the next or the new development we have done. For sure, if we compare laser P, which is a 2-axis scanner, with a laser S, which is 3-axis scanners, we will achieve, will do the job, but quality-wise, but also and also machining time-wise, they will have a big difference.
Okay.
Could be depending on the shape, depending on the texture. Time saving of 2 to 3 times using a laser S compared to a laser P. But not whole parts or shape needs a laser S.
Yeah.
If it's a flat, don't need.
Yeah.
Then for the femto, this is different. This is mainly for micro engraving, micro machining, and more requested on mold making, but more for lighting and also packaging, because we can do very nice texture without burrs, without very sharp textures. And this is one of the purposes.
Okay, so this was the small introduction to the product and to the laser texturing. We wanted to go a little bit more in detail because it is still relatively new technology for mold makers, and we can see the value it brings to already the customers who are already using it, engaging with the laser technology in their production. And we just would like to present this to everyone so that you know about the potential and you know about what are. Now we take a small 5-minute break before we go forward in 2 small application details about how they are machined in combination with milling. Yes, Bob, I think you had some comment, but you are on mute.
I think it's probably better we just carry on straight through.
We carry on?
Yeah.
Okay, good. So if you have a break already, bring your coffee back.
Okay, so we got a very nice introduction on laser. Now we will move forward to 3 simple applications: PET blow mold, rigid plastic injection mold, and a forming mold. We specifically choose 3 applications which looks like you can see it around the house, and we are trying to speak to mold makers and trying to understand and show the value we can add with our solution, even on the simple molds. If we can add a value here, obviously, if you are doing a complex automotive lighting mold, there will be a definite 3-5 times value with the same solution.
Absolutely.
So to start with, let's start with the first application, which is a PET blow mold. So as we know that it's a 3-segment mold, usually made in aluminium. We apply our process of pre-milling and machining the cavity in a 5-axis milling with mill S400U, and then we will use the milled part with our laser machine to see how we can address all the texturing and all the engraving requirements on this mold. So to begin with, we have the first kind of application description, I would say. We did the blow mold in 5-axis milling, as you can see here. We arrived at the machining time of 6 hours 32 minutes for the larger part, with a surface finish of RA 0.03 micron.
Wow.
So it's already close to polished surface.
Means in milling we are able to do polish surface to avoid to do manual polishing, which is especially in mold making usually a bottleneck.
Yes, yes.
Wow.
So ideally, or in this description, we can save up to 8 hours of polishing time on this. Okay, and we use the OSS Extreme, which is basically like a operator support system, where you can choose to prioritize surface quality, accuracy, or cost or time. So these are small parameters in the software system. We applied it and we achieved this result. We also did the bottom part in 1 hour and 11 minutes, again to match the same surface quality of 0.3 microns. Here we save an additional time of 3 hours for polishing, and we applied the same parameters of OSS Extreme, which is available on all our high-speed machining.
Okay. And here every part has been mounted on system 3R pallets
Yes.
to be able to transfer them
Yes.
to the laser.
It's a simple clamping system of our system 3R, which is our own. It can be used once you have done on other GF machines or other machines, whichever the customer has in his store. After this, we applied the laser technology.
Yeah, there were few different parts for sure. This is a 3-segment. This is not exactly right side and left side are not exactly the same, but they are matching together.
Yeah.
This is something very important, to have a continuum of the texture around this 360 cylinder. There were some features, different design with logos like a GF we put. We can see our mountains behind us. And this is quite deep texture. You can see here it's minimum 0.25 millimeter, but could be down to 0.5.
Okay.
Same, this is quite fast. Here you can see the numbers. This is very interesting to see. And we were, for sure, compared to chemical etching, it was the way to make these parts before. We are really productive, and especially, and this is not too much mentioned here, but this is fully automated, 24/7, because this is a high demand for bottling systems. And also mastering etching on aluminum, this is not easy. It's going too fast.
Yes. I can imagine, because aluminum is a little softer compared to steel, so you need to have
Absolutely.
I would say more control over the parameters you choose and how you machine.
Absolutely. And don't forget or remember that for etching, one of the most, I would say, the longer time is to protect the part before doing etching. The etching process itself, this is very fast. This is some seconds or minutes. But to prepare and protect the mold, this could take hours
Yes.
or more.
Okay. So I guess we have a small video to
Yeah.
show the laser functioning and preparing the texture and all the elements which we saw before
Yeah.
in a 5-axis setup.
As you mentioned before, Anurona, here we are working batching by batch.
Mhm.
We move 5 axes and then we apply the texture with the scanner. This is positioning. It's a 5 axis positioning plus laser engraving on the surface.
Okay.
But we can see here, this is an automated production here with this System 3R palettes. Coming from the right or the left of the machine is depending the setup of the customer. This is important to mention. One thing is also not shown here. From one machine to another, the part has to be clean. Means removing the lubricant, chips, and so on, because this will affect for sure the quality of the product.
And we can integrate the cleaning system in our automation.
Absolutely,
line.
absolutely. The washing machine we can add could be done also with automation.
Yeah.
And this is quite common.
Okay. And the same clamping what we saw in this video can be reused, can be started with milling, goes to the washing, ends up in
Yeah.
laser machine.
And eventually then back to a CMM for control, for example.
Yeah.
It's we are mastering, thanks to Workshop Manager, this full process automated.
Okay. So that's a good example, and obviously, like we said, we have a lot of advantages of preparing different elements on the blow mold, and also but achieving better productivity and the cost and quality repeatability against traditional or conventional processes.
On top of that, we didn't mention this point before, but as soon as it is 3D representation, we can do real 3D rendering to see the product before, for sure, in virtual, before texturing, to have a conversation with the designer, product designer, to adjust, if necessary, some final details before engraving.
Okay. To make sure that the textures are aligning, the product looks what they want it to look.
Exactly, to fulfill the requirement of the product design.
Okay, so let's go to the next example, which is a very interesting one. I guess it was before my time or in GF or maybe at the beginning.
No, it has been done with the collaboration of our neighbor in Geneva,
Yes.
Dupont de Nemours, who are really, I would say, present into the packaging, and this was a specific plastic tough to inject. No, it has been done a couple of years ago, maybe 5, 6 years.
So just to explain this application or the mold. With Dupont, we established a small partnership. They were trying to test chemically resistive plastic which can be used to replace the glass in perfume industry. Why is this? Because the glass is more recyclable, but the process of manufacturing the glass creates lot of gas which are environmentally harmful. So if you are able to replicate the glass from the perfume industry and use a plastic instead, this improves the overall impact on environment of your production chain.
Yeah.
So this was the motivation, and this is the plastic which we created the mold for, and they applied it using their own injection molding process.
And also design-wise, here the replication of plastic it's far better compared to glass molding.
Yeah, I will assume that. Okay, so in this process again, as you will see further, the cavity is quite complex. So we use a combination of our 5-axis milling and 5-axis laser solution to first create the cavity and then apply the textural and the branding features to get the final plastic part. The material we use is 1.2378, so basically mold tool steel. So we start with 5-axis milling. Of course, looking at it, you will say, obviously, for this, you have to use 5-axis milling because it's quite visible in terms of, how the cavity shapes. 5-axis obviously will bring a lot of advantages because you can access, you can have in single setup, multiple side, you can machine, you can use a small, stiffer tools, and you can optimize your process. But what if this cavity was also somebody tried to do it in 3-axis, or if there are cavities which can be done in both, what could be the advantage of 5-axis? To briefly explain this, we have a small description coming from our application engineers. So basically the point is you have in 3-axis a tool. To get a very good surface finish, you need to use a bull nose tool. Okay, you have a setup in 3-axis, you have a setup in 5-axis. Okay, the way you approach the part through your tooling is the difference. You want to achieve good surface finish, but the problem is in a 3-axis setup, the tool which can bring you the best surface finish will have a center velocity at the tool tip which is 0.
Yeah.
So basically what you are doing is you are scribbing the surface.
Yeah, you're not cutting it.
You are not cutting it. But with 3-axis, you can have the impact on the tool at the right angle, which will improve your machining time because now you are cutting. Second, it will also allow you to control yourself on the 3D complex cavity. So you get a better surface finish and faster machining. And the impact of both of this is you can save the time because obviously in the first you are losing the time. You can have a better tool life for a longer time and a good surface finish can be achieved with a 5-axis.
Yeah, and having this good surface finish at the very end, you will save time also. It's not mentioned here on polishing.
Yeah.
Because if you have something which is a bit scratch or damage, you will have to put much more effort to polish and eventually make a variation, deformation of the shape, while it's not happen in 5-axis in this case.
Yes. So it's a cascading effect. You
Yeah.
buy a 5-axis, then you don't want to run a 3-axis. Then you have to go there first. So once we prepare the 5-axis milling, the cavity of this mold, we again go back to the laser technology to prepare in detail the textures on this mold cavity.
What has been done here, you can see this is a repetition of same pattern over the surface with some limitation in terms of connection. This is also a two-side cavity. It's a 4-side cavity because there is the neck ring, the bottom, and the two half of the cavity itself. We took the feature in the center, which is the design. Then we moved to Photoshop or GIMP in this case, which is an open source tool, to replicate this feature, this pattern over a surface. And then we wrapped this texture on the surface to be able to improve. And each single feature has been machined in one single position. And then we moved to avoid what you mentioned before, the patch line. There is no patch line because this is isolated features in this case.
Okay.
And it was required by the design.
Okay. So we have a lot of serial of these textures, but in fact the texture is just one and we are replicating it with the laser machine.
Yes, in this case. This has been replicated into the bitmap made into Photoshop, and then we do a UV mapping of the texture over the surface.
Okay. So our customers or our clients can also use even a small, somewhere they find an inspiration to create something,
This is the case.
and then it can be
Yeah.
replicated over the whole mold surface or wherever they wish.
Exactly. Yeah.
Okay.
This is selective, by the way.
Okay, great. And we gain some productivity.
Yeah. And this
compared
is
to-
compared to laser P in this case,
Yeah.
because we can use a larger, as shown during the video before, we are using a larger scanning field, and also this is a smooth slope,
Mhm.
means we can cover a larger area of machining using laser S technology.
Okay. So this is what we achieve on the plastic. Okay. So guys, just remember this slide. With laser machine, you can have a digital texture, whatever you want. You can replicate it to have a proper quality control over all of your surface, okay, which then impacts what you achieve on the plastic part.
Yep.
In great details. So you can have a full replication. You can have just for look and feel aesthetic,
Mhm.
or you can have the functional also. It can be
Yeah, for example, for demolding release functionality for the core. It's not for the cavities, but for the core.
okay.
This is also another topic, but we will not cover this point today.
We move forward.
Okay, so we go to the last part of the recorded session now. And then we close with a small customer test for today.
We move forward. Just a small kind of summary
Mhm.
of the mold making conventional surface preparation technologies, like it could be etching or die sinking, and what we are able to do with laser texturing and how it can improve the existing and the current processes, and how mold maker can use our laser technology to integrate in their own production areas. Obviously, from the cost point of view, die sinking uses electrodes, and there is a long process of preparing the electrodes, milling, graphite, so there is a lot of cost involved in equipment, in process. In if we compare it to the chemical etching process, it has a manual cost, but now more and more we see it has an environmental cost. Just before he told me that in China it's already in the
Yeah, in some,
pipeline.
yeah, in certain province there is
Yeah.
taxes.
Yeah.
There are taxes to be able to use such capability of etching.
Whereas with our laser technology, in terms of cost, you have no tooling cost.
No, nowhere.
Process is automation. You buy a laser, you can run a laser.
Yeah, typically, and for sure you can
Yeah.
put several parts on the pallet and
Yeah.
so on. There is different level of automation.
So obviously, from the cost point of view, it has certain advantages over most, if not all, of the technologies.
Yeah, we can run 24/7 without, I would say, fear because it's repeatable. Really.
So the second parameter, what we use in the production area usually is the productivity. So we know that die sinking process, even though we love EDM, it is still a little slow process because it needs lot of time. It's working at the electron level. It's
Well, laser works at photon.
yeah. Okay. And die sinking, obviously, you can automate to relatively some extent using the electrodes or integrating machine milling and other processes into your die sinking. Whereas etching, which is a popular technology still, is involving lot of number of steps, masking, then removing, then checking, then I don't know. There are a lot. This I know.
Absolutely.
And also they require a lot of manual process.
And
So-
very skilled people.
Yeah, skilled people and working with their hand over a long time, which obviously impacts productivity very highly.
Yeah, you
Yes.
work. People need to sleep. Robots, time to time, not.
And with our laser machining,
Ah.
you can do in automation this
Yeah.
process. You can have a multi-function like what we discussed, many features in a single setup. You can have as I was speaking, I remember one more additional. Mold makers make the mold, and then you have etchers. You have to send the mold to the etcher. So it's not just the process of etching; it's also the logistic of integrating the etching, which also takes time.
Yeah.
But laser could be integrated directly at the mold makers.
Yeah, because you can. This is a good point, Annie, because you can prepare
Yeah.
your job
Yes.
ahead of making.
Yeah.
Means while the machine is laser machine is running for the previous job, you can prepare the next,
Mhm.
and you will use the tool you are using also for 5-axis milling.
Mm.
Means CAN model.
Mm.
We will use the same CAN model.
Yes. So it's again a value could be added by integrating this in your own house, and you have the ownership of the whole
Absolutely.
manufacturing process.
Absolutely.
Then we go to the third parameter, which is quality. So die sinking, we know it is repeatable, fairly repeatable because electrodes sometimes behave differently. Then it depends on the tooling and also the process behind the preparation of this tooling. Whereas to control the etching or the chemically assisted, electro assisted, different type of etching process, you can control in 2 dimensionals, but you have manual control in when you are doing a masking.
Mhm.
It's a manual process. How much can you control? This is again the point. It's
Yeah,
a
but-
limited control.
And also to control the temperature of the bath,
Yeah,
the humidity, and so on. This is
true.
the science.
Whereas on the laser, you have to just control what buttons and values you enter. Then you have a repeatable process. You can replicate today or in 5 years. You can define the parameters depending on the exact surface requirement you have,
Absolutely.
and you have a proper mold surface to exact specification what you need.
And we are really, I would say, fair here because we are delivering die sinking or EDM
Yes.
machine. I'm coming from previously from EDM for some decades, and this is easy or much easy or easier for us to identify and to help also to support our customers to select or to define what is the best process. Because some cavities, EDM will remain the solution. If you talk about ribs, grooves, very narrow,
Deep ribs.
you will use an EDM because milling cannot and laser will not.
Yeah.
Too. This is a combination of different technologies.
So just on this point, obviously we can make the molds, but it's not still enough.
Yep.
You need a plastic injection also. You need to have the expertise or a proper control over the injection process, because you might have the best mold, but if you don't have the control over injection, you will not get the best part. That's why in our company we are working also with Rocktool, which is an injection molding technology supplier. We work with them to create a lot of applications, solutions in different industries, and follow the new trends to create molds and plastic parts to demonstrate what is the possibility and what are the market requirements.
Yeah, we have 2 examples here. We can talk about this point. On the left-hand side, this is this cavity with, you cannot see very clear, but this is typically a carbon fiber texture. This is very fine texture. We are talking about few microns deep. And to be able to replicate without using paint. And this is the goal here. is
Mhm.
to have a very nice, very detailed surface without paint. And to replicate such a very fine texture, you need a means, a way of making injection with very high reproducibility. And this is the purpose.
Okay.
On the right-hand side, this is a lighting rear lamp mold. Here it's different. There were few injection gates, and to avoid the welding lines or to have a very smooth and homogeneous surface, we have used this Rocktool technology to get out these welding lines and to improve the mechanical property of the parts.
So in this partnership, GF Machining basically is a provider of metal cutting, metal removal technologies, milling, laser, ADM. And Rocktool is a partner who brings the injection technology expertise. Combining this, we can address a lot of challenges, like we saw 2 examples, but then there are more. Like we can have high gloss surfaces, we can have replication on different type of plastics.
Absolutely.
And I think you mentioned something about bio-inspired or bioplastics.
Yeah, biosources plastics and also recycle plastic, and while keeping still the glossiness, because this is when you use recycled plastic, this is a mix of new and recycled ones. And time to time, if you don't use the proper injection molding technology, you will get a weird surface. Using such technology from Rocktool will keep still the glossiness and the quality. And this is more and more important. And to not adding waste, but recycle what we do.
So just for the customer who are interested in using this kind of recyclable plastic, you have plastic in your recyclable, but it's coming from different processes and also from a different lifespan. So they have some impurities already inside or a breakage of bonds. So when you want to use it to re-inject, you have to apply a kind of a high temperature so that you kind of harmonize all the bonds which are in the plastic and liquefy it to the normalized manner. And then you can inject, and then you will get a part which is looking like it coming from one single plastic, not parts of plastics. So very interesting technology. We are working with Rocktool a lot. We are showing at different events, and also when the customers visit our plants, the applications we are developing.
We associated also our strengths to work on the sustainability, because on the laser side, we are not using, I would say, wasted. There is no lubricant, just, I would say, dust. Dust is just such. On the other side, we remove, or we try with the help of Rocktool to remove the paint on the part, which is costly and also environmentally not the most sustainable ones. And this is the reason why we worked to improve this way.
Yeah. Okay, so I hope you guys like the introduction with.
Okay, so thank you for that. We are limited by time, so I would directly go to our small customer testimonial, and then we will have maybe 10 minutes for Q&A. Okay.
If I could just interject there, if any of the delegates present do have questions, if they could just jot them into the chat box so that we can deal with them sequentially. Thank you.
So as we know that now, I hope it it's clear that what GF is doing through various technologies. We also are working on digital and automation, and we would like to shortly present a small story from a customer. It's related to automation of the mold manufacturing process, starting from electrode to steel to die sinking, and creating a value chain within their organization so they can benefit from local as well as international contracts. So the story is about Robust Plastic. It's a it's a medium-sized company located in Austria, and they create products from for automotive packaging, recycling, and also crates for handling beers, bottles, and transportation. They do the product design, tooling design, manufacturing, assembling, all in-house. A small video of their factory. So we go to what was the discussion. This is interesting point because usually the customer, we arrived at, okay, we would like some capacity in producing electrodes or molds, but we would like to understand or we discuss more with the customer that what was the expected value and what was the real business goal. And in fact, once we on the discussion, we arrived with the customer that the real value and the business goal was not just the production capability, but also the benefit to produce in Austria, to be able to win local government contracts to produce parts for municipality. And on arrival of this, then we proposed a solution which was accepted. The solution consists of producing graphite electrodes, cavities. It includes the CMM machine, the storage of cavity, steel, electrode parts, and the positioning, and part handling robot. All of that linked with the System 3R workshop manager. Just one more point I would like to add here is in Europe, GF has company and sales teams in every countries, but like in the study or this story, all of the European team work together to serve a customer who is based in maybe Austria. Like here, the installation was done by Austria, Czech Republic, and System 3R in Sweden. So the team works even if you are in Portugal or Italy, you get the support from the all European. Finally, just the solution video from the customer, and I got a message that our previous partner in GF, Christian Pianchenko, who is in audience, would like to just say that he was part of featuring, or he was part of our this testimonial creation when he was in the GF. because I would like to just add one comment. The solution was important for the customer, not only to produce parts at the same rate in Austria, out instead of Hungary, where they had a plant, but also to attract new employers, which were mainly younger generation. The younger generation were attracted to move to a company nearby, which was not working mostly with hand but on computers. And in this way, they were able to attract some automation engineers, some young generation, and keep them in house. So this is also another point which the mold making industry and us should look into. The new generation wants to do things in a new way. So we have to provide them to keep them into our industry. With that, I would like to thank everyone and provide briefly speaker information for today. Unfortunately, we didn't had Pascal joining us today or the session with digital because of the time constraint, but I hope he will join us in future session. Thank you very much, and we are open for questions. You are on mute.
Thank you very much. That was a very interesting and exciting presentation. You guys set a very high standard. We've already asked anybody who's got questions if they could actually just put them in their chat box, otherwise we can't hear them. I don't think we've got anything coming through, Manuel. Is that correct? Have you got anything on your side?
No, at the moment we don't have any questions coming from the audience. I don't know if you have any comment to the presentation made by GF and Aniruddha.
I think maybe he's done such an incredibly excellent job of explaining himself. They're all trying to digest this. Let me just add that this presentation will be posted on the ISMA website. So if you need to collect your thoughts and ask very detailed or precise questions, they can still be logged on the website, or you can go into dialogue directly with the GF group, and I'm sure they will deal with you accordingly. Manuel, I don't know if you've got anything more you'd like to add. I think we've covered it more or less now.
Yeah, you're right. I think we got it, and it was a very comprehensive presentation, a very intensive one, and I think with a lot of information to our audience. So great to hear from GF, from Aniruddha, from putting people together. Oh, we have a question.
We have a question from Stefan. Hang on, I just lost it again. From Stefan Okamp in South Africa. How do you handle repair on laser etching? If any damage occurs, how do you handle this in regions where there is no equipment available?
So first thing, we don't do etching. We only provide the laser solution or the laser machine tool equipment to the etchers or to mold maker. If there is a damage on the etched surface, we can support in creating or replicating and making strategies or solution with the customer, but we are not doing any more machining from our side. So if there is a damage in India, it is possible that the laser machine was there at the customer side and there was a damage. And if he needs a correction on the mold surface, we can help him to decide on the strategies, but we will not do the machining.
Okay, all right. I think Stefan probably has a lot more comments to make about that, but maybe he should actually put his comments in writing and actually maybe go into direct dialogue with you. Okay. Okay, the hour is great. We actually promised everybody we would keep this to the 1.5 hours, and we're literally 30 seconds away. So I'm going to close off by saying to those of you who will be joining us in Stuttgart next week, I'm really looking forward to meeting you and shaking your hands. For those of you who still are interested in coming and haven't yet booked, please go on the website or look at your emails, register, join us in Stuttgart. We need to get things moving again. And the only way we're going to do that is with physical contact and networking and get our act together. So, yep, let's see you in Stuttgart next week.
Okay.
Can I bid you all a fond farewell? Thank our excellent representatives from the GF Group for an outstanding presentation. Thank you and goodbye, everybody.
Thank you. Thank you, everyone, for joining, and goodbye and good evening.
Good evening.